Lesson 3.1, Task 1. Investigate the graph of the parent cubic function. You previously worked with linear functions f of x equals ax plus b, where a and b are real numbers and a is not equal to 0, and quadratic functions f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. Now you will work with cubic functions, which are a type of polynomial functions that have the standard form f of x equals ax cubed plus bx squared plus cx plus d, where a, b, c, and d are real numbers and a is not equal to 0. First, you will investigate the parent cubic function f of x equals x cubed by analyzing its graph. Alright, so the graph of the parent cubic function f of x equals x cubed is shown. The curve passes through the ordered pairs given in the table. Alright, so you can see here is the graph, and they've got 5 points identified here on that curve, and they have those points here in the table. Alright, so it says sketch a graph of y equals x and y equals x squared. Alright, y equals x is just a straight line that is a diagonal that goes through the origin, and x squared is a parabola, a curve that goes also through the origin, but is a U-shaped graph. Alright, it says notice that the domain of all three parent functions, y equal x squared, and y equal x cubed, is the set of all real numbers. That means it goes left and right. Your domain is your x's, left and right, forever. How do the ranges and in behavior of the three parent functions compare? All right, so the range of y equals x and y equals x cubed is, all right, so y equals x is above. Let's graph, just so you're looking at the graph here. Alright, so y equals x, hit graph. Let's do zoom 6, make it a 10 by 10 window. Alright, so you have the cubic function here, and you have the linear function here. Alright, so the question says the range of y equals x and y equals x cubed is all real numbers because it goes up and down forever. The range of x squared, all right, if we graph x squared, U-shaped graph, so the range is everything above 0 on the y-axis, okay? So that would be the range of y equals x squared is all real numbers greater than or equal to 0. The end behavior of y equals x and x cubed is, so the end behavior of the line, as x goes negative, y goes negative, and x goes positive, y goes positive. All right, so as x goes negative, y goes negative. As x goes positive, x goes positive. All right, the end behavior for x squared. All right, so the parabola, as x goes negative, y goes positive. And as x goes positive, y goes positive. So these go positive on both sides for the x squared term. So as x goes negative, y goes up. And as x goes positive, y goes up. So the end behavior and the range is a little bit different for the x squared versus the x cubed. All right, it says use the graph of f of x equals x cubed to identify the following information about the parent cubic function. What are the zeros of the function? All right, the zeros are where it crosses the x. You can see it crosses the x at 0, 0. On what interval is the function positive and what interval is the function negative? All right, it is positive, everything above 0, okay? And then here it would be negative. So if it's below the x-axis, it's considered negative, and above the x-axis is considered positive. All right, so the function is positive on the interval 0 to positive infinity, and the function is negative from negative infinity to 0. On what interval is the function increasing? All right, from left to right, you can see that it goes up and continues going up. So it's increasing on the whole function. So from negative infinity to positive infinity, it's increasing. So where it's decreasing, so it does not decrease. The x cubed will never be decreasing. All right, how do these features compare to the same features on the parent linear and quadratic function? With which function do the graphs f of x equals x cubed have the most in common? All right, so the linear function is going to be increasing from left to right. So it's going to be increasing on the same interval. It will never be decreasing. And the end behavior would be the same. And also where it's positive would be 0 to infinity, and it's negative from negative infinity to 0. So it has the most in common with y equals x. And the differences, let's see what it gives us for sample answers here. So the features are the same with the parent linear function, which y equals x is the linear function, and different from the quadratic function. The function is most like the parent linear function. The differences are due to the different left side behavior of the graphs of the function of the cubic and quadratic function. So where the quadratic function is curved, that's what makes the difference here, because this comes, this makes a U-shaped graph. So the range, the end behavior, all those things will be a little different. All right, it says recall that an even function is a function in which f of negative x equals f of x, and an odd function is a function in which f of negative x equals negative f of x. Is f of x equals x cubed an even function or an odd function? All right, so this one's going to be an odd function. All right, and that comes from the symmetry. All right, how does this classification compare to the parent linear and quadratic functions? So it's going to be the most similar to the linear function and opposite the quadratic, or different from the quadratic function, which is what it says here as well. That's all for task 1. If you have any questions, please let me know. Lesson 3.1, task 2. Investigate the graphs of parent polynomial functions. A polynomial function of degree n has the standard form p of x. And you can see here how it's written. This is just a mathematical version of how it's written with the subscripts a to the n minus 1 just means it's decreasing by 1 each time. And also the powers n minus 1 will be decreasing each time. Where a to the n minus 1, and so on are real numbers, and a to the n is not equal to 0. That means the leading coefficient cannot be 0. With any polynomial function, that's the case. All right, so the values of all these different leading coefficients are the coefficients of the expressions in a to the n, x to the n, so on, and a to the 0, which are the terms of p of x. Note that the constant term a0 appears to have no power of x associated with it. The term is actually a to the 0, x to the 0, but since anything to the 0 power equals 1, you can write this as a sub 0. Polynomial functions of degree 4 are called quartic functions. Quartic, think of quartic is always going to be 4. And then the polynomial functions of degree 5 are called quintic functions. Polynomial functions of degree greater than 5 are generally referred to using their degree, as in a 6th degree polynomial. Graph A shows the graph of f of x equals x, x cubed, and x to the 5th. Graph B shows x squared, x to the 4th, and x to the 6th. All right, so identify the domain, the range, and end behavior of all the functions in graph A. All right, so you can see that the domain goes left forever and right forever, so the domain is going to be all real numbers. The range also goes up and down forever, so it's also going to be all real numbers. And the end behavior, as x goes negative, y goes negative. And as x goes positive, y goes positive. All right, so identify the domain, range, and end behavior of all the functions in graph B. So you can see the domain goes left and right forever, so that would be all real numbers. The range for each of these is above 0. So you can see that the range will be 0 to infinity. And the end behavior, as x goes negative, y goes positive. And x goes positive, y goes positive. So in this case, as x goes negative, y goes positive, and goes positive on both sides, basically. So determine whether x, x cubed, and x to the 5th are even, odd, or neither. They are odd functions, because negative x equals parentheses negative x. So because that happens, these are considered odd functions. Determine whether x squared, x 4th, and x to the 6th are even, odd, or neither. These are considered even functions. And that's because in parentheses, negative x squared equals x squared. So those are considered even functions. How can you use the graph of a parent function to determine whether it's even, odd, or neither? How can you use the equation of a parent function to determine whether it is even, odd, or neither? Well, you're going to see if it reflects across the y-axis or the x-axis. So the graph is even if it's symmetric about the y-axis. The graph of an odd function is symmetric about the origin. You can test each of these using f of negative x. All right, that's all for task 2. If you have any questions, please let me know.